Hello everyone, myself Shwetnisha. Today I have here your lecture planner of UPSC Mathematics. That's an optional subject in mains in UPSC. Most of the students, they already decide that they'll take mathematics as an option. So they have done the mathematics in graduations, whether in the BTech or BSc mathematics or masters in mathematics, right? And then when they prepare for the UPSC exam, they choose mathematics as an option. Now, first thing that you need after entering into this mathematic optional is how you will plan the whole things, because you know that it is one of the lengthiest subject in UPSC, right? And it has no overlapping with any of your GS subjects as well. So you have to plan it properly so that you save your time also, and your output of the input that you are giving in this exam, the output should also be very good. So the first thing that you need is a lecture planner, which means that everything should be planned. Within this much of time, you have to cover all of the things. This topic should not need more than 2 days. This topic should not need more than 5 days, like that. First, you plan those things, you complete the syllabus, and then you need a proper time to revise as well. Because mathematics is nothing but revision. More revision you do, more grasp you will get on your subject. Okay, so without wasting any time, let's start discussing your lecture planner. So in my class, this is the basic lecture planner, and these are the objectives that we have. First of all, art of writing subjective answers. Maybe you have appeared for some exams like IIT JAM exam, CSIR NET exam, or GATE exam. But you see, all of those exams are objective exams, right? Even if you know the answer, you just have a short trick to do that. You just see the options and you tick it. But when you are opting for a subjective answer, the approach is totally different. Totally different. So you have to work on your writing skills as well. How you will present the answer, that's very important. Also, when you are writing you're writing an answer, you're writing a solution, it's very important for you to manage the space as well. Because you know that in a sheet, if for example, one page, there's a question written, and there is a one page only for the solution. So you have to manage your space. You have to complete the answer within that space. For example, if you are writing the answers and you forgot something or you missed something, you don't have any space now. So now, even if you know the answer, even if you know this solution, you can not do anything. So you have to do that as well, managing everything. So this is the first point that we will do in our class. Number 2, proof of all important theorems. This is also important. Sometimes proof directly comes in the questions, comes in the paper. So we have to do that as well. To understand all the theorems and their application on the questions, it sometimes happens that you know the proof, you know what the theorem wants to say, but when it comes to apply that in a question, you get a problem. So we'll understand all the theorems so that you can apply very easily those theorems in questions, right? Next is handbooks containing all important theorems and formulas. It's very important after the end of your subject, after the completing the whole syllabus, you can concentrate on everything together. So you have to bring everything together, and this is the first step to do that. These handbooks you will make throughout our classes. So what you will do is, for example, I gave one lecture. So you take a page front and back. The whole first lecture should be on that first paper. So for example, if I'm giving 150 lectures, so at the end of the syllabus, at the end of completing the syllabus, you must have 150 page, each page representing each lecture, right? So if you are not collecting together everything at the end, that is of no use. Okay, because there's so much material, there are so many things to study. How will you do the revision at the end? You need something, and your hand written notes are important. Okay, and last but not the least, we'll have only the syllabus oriented classes, not more than that, not less than that. let's start. So paper one, I have roughly divided into 61 days. So roughly in 60 days. Paper one should not take more than 61 days. See, you can take the margin of few weeks here. Okay, so you can take the margin, and one of the portion that can be stretched is your analytic geometry in the paper one, and statics dynamics sometimes for those who haven't done this in their graduation. So maybe this can be stressed for you. But yeah, you cannot, at max, you can add 1 month to it, at max, right? But not more than that. So let's start. Let's start with the first syllabus for first subject, that is linear algebra. So I have given 11 days to it. 11 lectures will be there. So whole this linear algebra should be in 11 pages for you. Okay, it can be more than that, it can be less than that, but not like more than 5 pages, let's say. Okay, you can add more 5 pages to it. First, syllabus is vector spaces over reals and complex, linear dependence and independence, subspaces, basis dimensions, linear transformation, rank and nullity, metrics of a linear transformation. So the first five lectures or first 5 topics, I would say here, can be totally new to the BTech students here, right? They haven't done vector spaces that much in details, but if your background is from mathematics, like for example, you have done BSc mathematics, honors in mathematics, or masters in mathematics, then obviously you have seen this, right? And it may be when you start this linear algebra, this initial section, it may seems to be difficult, but you need to understand it's not difficult. It's just different. You haven't seen such kind of mathematics, right? That's the only point. Okay, so no need to be afraid. There is no portion, like there's no student for whom everything will be familiar. The syllabus of the mathematics optional is very diverse. So if you are from BTech students, from BTech background, engineering background, then modern algebra and this section of the linear algebra and few subjects will be totally new to you, right? If you are from pure mathematics background, statics, dynamics, fluid dynamics in paper 2, these can be a struggle for you, right? So it's not like for some student it's very easy, for some it's not. No, everyone has to do their part in some section. So this may seems difficult, but you do not need to forget that's why we are here, right? UPSC mathematics optional is not easy and you have to work on it. Okay, so yes, so these are the first 5 topics. After that, mostly everyone has done that: algebra of matrices, echelon forms, similarity, rank of a matrix, inverse of a matrix, solution of simultaneous linear equations. Everyone know that, right? Then we have eigenvalues and eigenvectors, Cayley-Hamilton theorem, and these we can just accumulate in one lecture. Some proofs are there related to the eigenvalues of some special matrices that include symmetric, skew-symmetric, Hermitian, skew-Hermitian, or orthogonal and real geometries. And this finishes your linear algebra. Next we have calculus. Okay, so there is a very thin line between a calculus of paper 1 and real analysis of paper 2. So usually in the classes, what we are going to do, we'll start with the calculus and we will do real analysis along with it in continuation, so that there's no break in the flow, because everything over here is needed in the real analysis. So I can say that in paper 1 and paper 2, these 2 subjects are really very connected. Okay, it starts from real numbers. Basic knowledge of functions and relations are required from your class 12. Okay, relations, functions, limits, all the calculus part. Calculus basically include limit, continuity, differentiability, integrability. Okay, so limits, indeterminate form, continuity, differentiability. Because this is of one variable, so it will not be very difficult to discuss everything in just one lecture. Okay, now next is mean value theorem, Taylor's theorem with remainder, and maximum minimum. Maximum minimum also you have seen in class 12th, but that is of one variable. Then we will enter in function of 2 or 3 variables in which we'll discuss these same things, limits, continuity, that can be new to you. Partial derivatives, maxima, minima over here as well. Then we have Lagrange's, and this is next. We have Lagrange's method of multiplier, which is very important. You will see questions after like every other year from this section. So this is important. You can't leave that. Along with the Jacobian, Riemann definition of definite integral and indefinite integral, although Riemann integration is as it is in the real analysis portion as well. Infinite improper integral, double and triple integral, very important. Of course, we are only discussing evaluation techniques only. It's written in your syllabus. So we are not going to focus on proof of the theorems. We can will use only the evaluation techniques. And the last is area, surfaces and volume, which is continuation part of double and triple integral only. Okay. Next we have analytic geometry. So if you find analytic geometry difficult, there can be one reason that you are not dealing with the subject in intuitive sense, right? When you are dealing with, like, for example, you are discussing about paraboloids or ellipsoid, let's say, right? The last sections I'm saying, or anything, plane, sphere, anything. Intuitive idea of every question, of every concept is very important. You have to go through the general proofs here because they are very, very helpful when you apply them in the questions, right? So, and usually the last sections over here, which is of conicoids, create problems, but don't worry. I'll tell you everything in an intuitive sense. I'll try to draw maximum pictures here because when you don't see actually what's happening, so it's very difficult to accept, and it's very difficult how to get to the next point, how to get to the next step. So even when you are reading the questions, it's very important that you make a mental picture. You make a mental image of everything. If it's a square and the plane is cutting a square, and what is the intersection? Intersection is a circle. All those things should be as an image in your mind, at the back of your head. Only then you can approach the subject. And this is, after linear algebra, I would say this is the easiest subject, right? So it starts from second degree equation in 3 variables, reduction to canonicals form, Cartesian and polar coordinates in 3 dimensions. The third point will discuss about it in calculus and real analysis as well. Then the analytic geometry starts with straight lines, plane, sphere, cone, cylinder, and the conicoid section. So you do not have to be worried about conicoids because, as I said, intuition is very important here. And see, one question from the conicoid will definitely be there, especially from that 6 normals. 6 normal from to the paraboloid, 5 normals to paraboloid, and 6 normals to ellipsoid. So these sections are important. You cannot leave it. Next comes ordinary differential equation. In the whole paper, in the whole mathematics paper, this is the easiest subject, right? Including paper 1, paper 2. So if you are still struggling in thinking that whether I should take it or not, I think you should start from ODE. You should start from ODE. This is the easiest one. If this you find difficult, I don't think that you should opt for mathematics, right? Because this is very easy. And if you want to pump yourself that no, I can do it, then also you can start with this. This is easy, believe me. Okay. So what it is, and you see, I have just taken 1 week here. 1 week to complete ODE is more than enough. Formulation of differential equation of first degree, first order, and integrating factor in the first lecture. Orthogonal trajectory equation of first order, but not of first degree. Clauret equation, very important. Singular solution, right? Second and higher order linear equation with constant coefficients, complementary function, particular integral, and general solution. At the end, this third topic, I'm telling you with the guarantee that this will be your favorite topic in ODE because this is very easy. Next is second order linear equations with variable coefficients. Euler it was Cauchy-Euler. Anyways, it's not Euler-Cauchy, it's Cauchy-Euler. So Cauchy-Euler equations, determination of complete solution using one solution is known. Variation of perimeter. You will always see a question from this section, so you cannot leave this. Laplace, from Laplace also you see one question every year. Laplace and inverse Laplace, their transformations and their application on the initial value problem. So basically their application, Laplace application to solve the differential equations. Okay, this is about your ODE. Next comes statics and dynamics. So yes, there can be some problem in the starting when you start these subjects, but especially for those who haven't done this in their graduations as well. So it can be the problem, but no worries. We'll start from the very basic. And yes, this can be stretched from 11 days. This can be stretched to 14 days, 15 days, or sometimes 20 days as well, right? Because it depends from how basic you want me to start. So sometimes I have to start from the very low level and I have to cover all the things. So it may get stretched. But the main part is equilibrium, friction. One question definitely from equilibrium. Stability, stable equilibrium. Sorry, not in this one. That is later. Yeah, stability of equilibrium, common catenary, very important. Again, principle of virtual work. One question from principle of virtual work is always there. I'm telling you, some of the subjects, it includes analytic geometry also and the statics and dynamics also. Some type of questions are continuously repeated. They are continuously repeated. So if I'm saying, if I'll also give you the material, see, from one particular subject, if I'm giving you one particular PDF, like for example, static, you have to cover from this PDF. Then I'm telling you maximum questions. You can also tally this. You can also match this from the previous year questions, that most of the exams are just from this PDF, right? So we will do all the questions from them. Okay. Same goes for dynamics. Dynamics, rectilinear motion, simple harmonic motion, very important. Projectile, motion in plane, constrained motion, work and energy, conservation of energy, and Kepler's law, orbits under central forces, right? These are the topics in your statics and dynamics. Now, vector analysis is another very easy subject. Starts with scalar and vector field, differentiation of the vector field of a scalar variable, gradient, direction derivatives, equation of tangent plane, equation of normal, angle between the two surfaces at a point, divergence and curl, higher order derivative, vector identities and vector equation, application to the geometry, curvature and torsion, Gauss and Stokes theorem. Eighth question of your paper one. Paper one, everyone know about the basic structure of both of the papers. If not, you can tell me, I'll make a video on that as well. Okay, so paper one has two parts, part A and part B. In part A, we have 4 questions, 1, 2, 3, 4. In part B also 5, 6, 7, 8. Eighth question is definitely, you will definitely find, you take the previous year question of any year that you want. Eighth question will always be from one of the theorem, Gauss theorem, Stokes theorem, or Green's theorems. So of course we cannot leave any of them. Syllabus, within the whole syllabus will leave nothing, because see, you need to remember this. If you compare a few subjects, for example, if you are comparing ODE with the fluid dynamics, right, you will find that this is easy, this is much easy than fluid dynamics, right? So what you will do? Will you decide to leave this? No. Why I'm telling you it's not a good choice? Because sometimes in ODE, you will get a question that you cannot attempt. It can include sometimes proof of the theorems. That happens in 2022. In 2022, there is a question in ODE, which if you are spending like 10 minutes on the question and you're not able to solve it, just leave it. And that was a question of a proof of a theorem, right? So what does that mean? Now we have to do all the proofs? No, that doesn't mean that. That just means that you have to leave the question. So the ODE that you have done and you believe that you will be able to do the question in the exam, you were not able to attempt the question. Now, if you have done only even the basic things in fluid dynamics, the basic definitions, I'm not telling you to, do every kind of question in fluid dynamics, whether it's level 1 to level 2, level 3. No, even if you have done level 1 questions of the fluid dynamics, it may happen that in the exam, you are not able to attempt ODE question, but you are able to attempt fluid dynamics question. That's why it's very important to, first of all, go through all the syllabus. everything. Okay, because you can't take the risk. So moving ahead, paper 2. In paper 2, maximum 72 days. Again, you can take a margin of few days, few weeks. Okay, not more than a month. Let's start with the algebra. Algebra section is one of the lengthiest in all of them. As you can see, 21 days I have not taken in any of the subjects. So 21 days in the first subject of paper 2, which is algebra, modern algebra, or we also say abstract algebra. It includes groups. Algebra is roughly divided into 3 sections. The syllabus is roughly divided into 3 sections. One is groups, rings, and fields. Okay, so as you can see, till here, 6. Till here, we have groups. Okay, and from my experience of teaching, I observe these things that when I start with the algebra, and in fact, the linear algebra that you have seen, the first subject, the first section, remember the first section of the vector space in the linear algebra. And when I start this algebra, students come to me and they are like, ma'am, do you think that we should switch from mathematics software to any other subject? You need to understand mathematics. You have taken mathematics for a reason, right? You love this subject. You want to learn more about it. So this is something that you are learning. If these things are new to you, please don't be afraid. It's just that these kind of mathematics have never been taught to you. That's the only difference. Okay. So don't worry when you do these subjects very first time. You may find some uncomfortability in accepting the subjects, but eventually you'll get it. Okay. So these first 6 is groups. So don't have to be afraid. Next is rings. Rings starts from here. Rings, subrings, ideals, and till here. Till here we have rings, and the last 3 is about fields. Okay, it will take time to cover. And once you complete group, you will see all the major concepts that are just repeated in ring as well as in field. Of course, there are some additional sections as well, but most of it are just repeating. Okay. Yes. Now, real analysis, as you can see, I have taken equal amount of time for real analysis as well. Real analysis is in the continuation of the calculus. Calculus, whatever we have done, will be needed here. Okay. So real number system as an ordered field with a least upper bound property, limit of a sequence, Cauchy sequence, completeness of a real line, series and its convergence, theory on partial sum of sequence, absolute and conditional convergence of series. This is very important. Absolute and conditional convergence, continuity and uniform continuity of functions, property of continuous function on complex set, derivatives of a function of single variable, application of derivative of a single variable, and then we have maxima and minima, right? Next we have, this is continuous portion of real analysis, partial derivatives, Jacobian, Riemann, improper, Dirichlet and Abel's test, improper of second kind, fundamental theorem of integral calculus, uniform convergence of sequence and series of functions. This is important as well as it's tricky as well. So you have to spend time here. Continuity, differentiability, and integrability of sequence and series of functions, partial derivative of function of several variables, maxima and minima. Next, we have complex analysis. Complex analysis will not take much of your time, and whether you have done it in your graduation, not done in your graduation, doesn't matter. This is easy. Complex analysis is very easy. Okay. So analytic functions, Cauchy's theorem, power series representation of analytic function, singularities, residue, contour integration. One question definitely from this section, and this integration section. One question will definitely be there. Right, so this is about complex analysis. Next, we have LPP, again, a very easy subject. It just goes in 5 lectures. Still, I have given 3 days margin of 8 days. So linear programming problems, first of all, we'll get to know about basic, like you can say terminologies, what are basic solutions, basic visible solution, and then we'll jump to the method to solve. This LPP is linear programming problem. One chapter you must have done in class 12th as well. Remember, you used to make a few equations. Then we used to make a table to get a maximum and minimum value, right? So actually, that's the same topic. We are going to discuss them in details. One method that you have done in class 12 is this. Only one method, graphical method. We used to make graphs, but there are much more methods. That is our target to complete, okay? And it's very easy. Next comes the PDE, a slight prerequisite, slight sections of ODE actually is required here. But even if you haven't done that, only class 12, if you have polished the knowledge of your class 12 differential equations, then also you can start with the PDE. Again, I have divided into 5 lectures, but margin I have taken here as well. So family of surfaces in 3 dimension and formulation of partial differential equation, solution of Cauchy linear partial equation, that is done by Lagrange's method. One question from this section to solve quasi-linear will definitely come. So in PDE, actually, there are 2 sections which are very important, Lagrange's and the last one, this heat equation, wave equation, and Laplace equation, this one. So one question can be from any one of them, either from Laplace or heat or wave equation, right? And one is from Lagrange's equation. Then linear partial differential equation of second order with constant coefficients in canonical form, that will also do. And characteristic, yes, this one is also. So syllabus is not very vast in PDE. We can complete that in minimum time, in less time. Yes. So mostly mathematics optional, when you take this, or when you are thinking about taking this, the main problem starts here, right? Computer programming, right? So you don't have to be worried about it, even if you have zero background from computer programming, because I'm telling you, there are few things that can be repeatedly asking. Okay, so in computer programming, we will learn some few things that are necessary and some flow charts. See, it's very important for you to save your time sitting in the exam, right? Saving your time can be done if you have already taken out some of the informations that this can be asked, right? So if I already know that this can be asked, so why don't I prepare that beforehand? Why don't I do that beforehand? So for computer programming, we'll make some flow diagrams, and you have to just remember those flow diagrams. Because you see, once you get the knowledge of flow diagram, it may be possible that sitting in the exam also you can draw the flow charts by yourself. But why to waste time? Why the thinking process and then making, then why to waste time when I know that flow charts will be there for these, for few methods and for few programs. So I'll just memorize them. I'll do the practice and I'll just copy it down in the answer sheet, right? If something else comes, then we have to work on it, right? But there are few flow charts that should be ready with you, right? And beforehand, you have to give a revision to them, and then you will. So don't worry about computer programming, even if you have zero background, no problem, we'll do that. Numerical analysis is another very easy subject. It includes solution of algebraic and transcendental equation of one variable by bisection, regular falsy, and Newton-Raphson method. Solution of system of linear equation by Gaussian elimination, Gauss-Jordan, Gauss-Seidel, and Newton's. That's it. Next, we have Newton's forward and backward table that we make. Interpolation, Lagrange's interpolation, and then we have integration that includes trapezoidal rule, Simpson rule, Gaussian quadrature rule, and last is numerical solution of ordinary differential equation by Euler and Archimedes. Okay, and then comes computer. Computer programming includes binary, arithmetic, and logic operations on numbers, octal, hexadecimal system, conversion to and from decimal systems, algebra on binary numbers, and basic logic gates, truth table, Boolean algebra, normal form, representation of unsigned integers, signed integers, double precision reals, and long integers. Easy. And then at the last, what I was talking about, algorithms and flowcharts for solving numerical analysis. So we'll be ready with these flowcharts. Okay, we'll be ready beforehand. Next and the last. Next and the last is mechanics and dynamics, to be precise, fluid dynamics. And although they have considered, UPSC considered these two subjects as one subject, but they are two different. So we'll do them separately, mechanics first and then fluid dynamics. It is difficult. Yes, it is. Okay. In the terms of the material, they are very limited. We have very limited material for both of the subjects. But as I just said in the beginning, that even if you do level 1 questions of everything, it may happen that you can attempt the questions, right? So you do not leave anything. Okay. So mechanics has the portion moment of inertia, D'Alembert's principle, Lagrange's equation, Hamilton equation, right? And then generalized coordinates, motion of rigid body in 2 dimension, equation of continuity, another very important subject, and Euler's equation of motion for inviscid fluid. Streamlined path of a particle, potential flow, 2-dimensional and asymmetric motion, forces and sinks, vortex motion, and Navier-Stokes equation. So this is all about your syllabus, how you should plan it, how you should divide it, so that you can complete it in time along with the revision, right? You must have a proper time left with you for the revision as well. And it's very important at the end to, I said that, to accumulate everything in one place, otherwise there will be a problem. Okay, so with this note, I hope this helps. This has helped you. Thank you so much.